Welcome back. We're writing Little Man Computer in C++, and last time we'd kind of got stuck a little bit trying to move forward with having multiple instructions being run, and we'd got as far as having, if we look down here, explicitly a sequence of instructions. But as soon as we wanted to just take it that one step further and move to using the program counter for the addresses, we kind of tripped ourselves up a bit. And so I want to revisit that today and see if we can do something about it. Now, one thing I did notice that might be hampering our progress here is that if we go down to these branch instructions tests, we can see here that we've kind of got it wrong. We've said, so for example in this test, that we're branching to instruction 7, and so we expect the program counter to be 7 when little man has run the program. But that's not quite true, because if we look at precisely the ordering of things here, we extract the instruction address from the program counter. We then take the instruction from the relevant mailbox, and then we increment the program counter. So on this second halt instruction, and that the halting is done as the last step, we would have already incremented the program counter. So this should in fact be 8 as the final program counter value, and the same is true for the other tests of the branching instructions, which I believe is just those 3. So if we run these, now we have a number of failing tests again that we need to do something about. And we can, I believe, just simply insert an increment of the program counter here, like so, and I think that will get us back to having correctly passing tests. Yep. But obviously this now looks really quite strange in the way we're doing things, as we've got this single program counter increment. So what we probably want to do is to try and tease out some proper use of the program counter for these run instructions, and then generalize that into some sort of loop. And I don't think we can do that as a simple refactoring straight off the bat. So what we need to do is introduce some failing test that moves us a step closer to that. And probably the easiest way to do that is to take one of our existing tests, possibly even this first one here, and assert something about the state of the program counter at the end of it. Now, in this case, the program counter should be 2 after performing 2 instructions. So if we were to say, add another test using that same test, but this time asserting something about the program counter instead. So little man interpreting input, then Manu2 input or output? I think it's output, isn't it? Doesn't really matter what the instruction here is. Output, then halt leaves the program counter at 2. So this should fail in isolation, leaving all the other tests passing, and we can start to do something about that. And now we could do this. However, that's going to break some of the other tests, particularly the branching tests, because there'll be an additional increment of the program counter. And there we see. Beyond this program counter increment here. So what we kind of want to do is some sort of halt check in here, I guess. How would that look? So we run an instruction, increment the program counters. The problem is here that we're incrementing at the wrong time, because here we're incrementing after the instruction rather than before. So that, I guess, is more the behavior we're after, like so, where the increment is done before the instruction. Does that look something more sensible? I think that will make our test pass. And indeed it does. Now, some sort of refactoring would be kind of nice, but I think that still breaks tests if we were to say just move this increment inside, as we'd like to do, inside the running of the individual instruction. I think anything because we'll continue running, because we're not halting, we'll continue to run through here. So perhaps what we need to do is to write an additional test to check the program counter after 3 instructions, which will then force us to put some sort of halt checking in somewhere. It still feels like we're drifting a little bit more aimlessly than I'd like, but let's work with it for now. So if we steal this instruction, this test body here, and change its assertion to say something about the program counter, we can then say that little man interpreting 3 instructions leaves the program counter at 4. And we'll see what that forces us to do to make it pass. So let's just check the failure. I suspect the failure will say 2 expected for, as we've only got 2 increments. So hello. What is going on here? we have not changed our assertion. This is the the risk you run of copy-paste programming. Let's try it now. And this is why it's also important to see the test fail before you move on to making the test pass. So now we can possibly do that, and then another one. Does that do something sensible? It'll make the branching tests fail, and we can address that. Yes, and the previous test. So what we need to do here, I guess, is to say if computer.memory 1 is 0, is not 0, we can continue. Does that get the job done? It does. Now we're starting to get quite a bit of mess here, and it seems like we're duplicating the increment quite a bit. The question is, can we move this increment inside our run instruction? It wants to go here. We sort of know that. And if I were to remove this, what then happens? How far away are we from having a correct formulation? We just have the one failure because we're not doing that final increment inside here. So do we need to do that to make the test pass? We do. It feels like, so it's getting a little bit nearer here, but it feels like what we need to do is to have a test for 3 instructions, and that might just get us over the edge for our specification. For 2 instructions, sorry. Hello, what have I done here? In fact, this has gone horribly wrong because I've put the wrong value in the program counter here. We're a little bit naughty, and rather than roll that back, just correct the test and see what that does. Yep, so I think that means we can take that away now, like so. Good. And then just one more here, where we'll just have a halt instruction on its own. So if we were to say little man interpreting a single halt instruction leaves the program counter at 1, and let's write this out by hand to avoid any copy-paste errors. So we are asserting that there's a program counter at 1 after the program. We have a man run our program. We create that man, like so, and then we have a little program that is simply a halt instruction on its own. And we then fix our missing comma, like so. And hopefully we'll end up with a single failure. Yep, because it's running all the way through. And so we kind of need to have the same check here that we did before. If memory 0 is not equal to 0, then we continue like so, and I suspect that might just about get the job done and leave us in a position where we can feel comfortable doing a little bit of refactoring. So this, I think, looks quite a lot like it wants to be a loop instead of something else. But let's take this cautiously and start by saying that this is the program counter instead of just literally the explicit address, and see if that still works for us, and it does, and that's good. And then here we need to say something similar. We need to say that this is not the program counter as such, but the program counter -1. And then we have everything in terms of the program counter. Excellent. And now it's starting to look quite clearly like a loop that we've manually unrolled. And I think we can probably dive straight in and do this, assuming that is the correct rephrasing. No. Yeah, yes. Something like that, I assume. That looks better. Excellent, very good. And now it becomes considerably more difficult to write a failing test. But we've got to the point where we kind of have something that looks like what we want it to look like. I'm not completely sure I like this formulation here of checking the previous value on the program counter, but I suspect and indeed does not work. It does not work because of branching. So we could write a failing test actually for that, just to make sure that we're not doing anything silly. So what we want to say is something along the lines of halt after branching terminates correctly. That's not necessarily the best name, but I think it gets the idea across. So what we want to say is assert r equal some number for the program counter, assuming that's how we want to do it. We'll come back and fill that in a moment when we know what the program looks like precisely. Run, nope, man.run. Create a little man, and we write a program that has a branch in it. So computer memory 0. Let's find our unconditional branch is 600. So we want to branch to instruction 2, skipping the next instruction. But what we want to say is that memory 1 is 0. And then that memory 2 is 0. Is that sufficient? So we should have the program counter pointing at 3 afterwards. So this will run. Program counter will point at 1, at 2. Then this will run. This won't run because the preceding memory address is 0. So that should fail. And indeed it does. Good. So what is the best way of approaching this now? So we could pass in the instruction rather than the programming counter. What does that look like? And also, this will let us pull this out and be a little bit closer to what we want. So if I say instruction here and pull that out, and then do this, like so, that should still have a failing. Yes, that is, of course. Now computer.program counter. Let's just check we still have just the one failing test before taking any further steps, and indeed we do. And then now we can replace that with instruction, and that should yeah, we can't see that from there. So we have int instruction and do that, which hopefully will take us to passing. Excellent. And then what I would like to do, just for clarity, as a sort of semi-refactoring type activity, is to pull that out and put that here, so that we're quite clearly doing the process of take an instruction, or read the program counter, take the instruction out of memory, then increment the program counter, and then run the instruction as we have here, and then halt if necessary. I think that seems slightly clearer code. Let us see where that leaves us. That's good. That's passing. Very nice. And I think that's a good place to leave it for now. Let us just commit those changes. Yep. So refactor to a loop. Adding some tests for clarification. I think that says it all. Excellent. We shall continue next time.